For the next example, is the second order differential equation and have two dependent variables. So, to find the solution of the linear system differential equation, you have to write down the differential equation in the terms of operator D. Now, if you take a look at the first equation, 3 times the second derivative of x, you would get 3 times d squared x. And the second term, you would get d squared y. And the third term, you would get 3dx. And the fourth term, you would get 2dy plus 2x plus 3y is equal to exponential of t. Now, any term which has x, you put them together and take x out. Okay, so you get 3d squared x plus 3dx plus 2x. So the thing is that you've got to rearrange the term because now you have two dependent variables. You've got to combine the term which has dependent variable, I mean the same dependent variable together, right? And any term which has y, you put them together. So you would get d square y plus 2dy plus 3y equal to exponential of t. The first three terms, they have x, so you take x out. The last three terms, they have y, so you take y out. You would get 3d squared plus 3d plus 2, the whole term times x, plus d squared plus 2d plus y, and the whole term times y. Put it as the equation 1 and keep it there. Now you have the coefficients of x times x plus the coefficients of y times y equal to function of t. For this equation, the same procedure. You write down the terms of operator d. You will get 2d squared x plus d squared y minus dx plus dy minus 2x plus y equals to 8. Again, you put the x term together and y term together. And y term put with the y term. Then take x out. And the last three terms take y out. I'm sorry, there, that's BD. That's the equation 2. Now you have two equations and two unknowns. You can find x and y, right? If you feel like equation 1 and 2 so far away, you can rewrite it down again in order to make you feel better that you won't mess it up. And then we can use Kramer rule to find x and y. To find f, you replace the function on your right hand side to the coefficient of f. And then you put the coefficient of y there, divided by the determinant of coefficients of x and y. Like that. And you do finding the determinant, you will get denominator, if denominator you get this and nominator you will get minus always don't have any space. There you go. Almost. The bottom I would get t to the power 4 I mean combine two terms after I got to do the product of these two terms minus the product of these two terms, and this is the answer. And on the top, these were et plus det plus et minus I would get 1 over d to the power 4 plus d 3d to the power 3 plus 12d plus 8. Okay. Second derivative of exponential of t is equal to exponential of t. The first derivative of exponential of t is equal to exponential of t and exponential of t. Second derivative of 8, 0. First derivative of 8, 0. Now you get only minus 24, which is equal to plus 8, right? 3 times exponential of t minus 24. You see? For your linear system, it's a second order. But when you rearrange in such a way that getting the equation contain one dependent and one independent variable, to find that, you go to the fourth order of differential equation. Right? From this, if you write it down in the terms of differential equation, you would get or wait, I'm sorry. Oh, that's correct. I thought it messed up with the variable. See, it's the order 4 of differential equation, and when I write down in this form, you'll be able to solve for the solution of this differential equation, right? It is a non-homogeneous differential equation, so your x is combined with xc and xp. To find xc, you got to write down the characteristic equation, and the characteristic equation of this differential equation is this. You got to find four value of m. Since you have all plus sign, so you know that the first root of it should be negative value. So we can try minus 1. If I try minus 1, I would get 1 minus 3 plus 6 minus 12 plus 8. Are they equal to 0? 6 plus 1 is equal to 7. 7 plus 8 is 15. Minus 3 minus 12 is minus 15. So we get 0. So that means one of the root is m plus 1. And then you use m plus 1 dividing this function. You would get m to the power 3 plus 2m squared plus 4m plus 8 equal to 0. Now, if I plus sign again, so that means you have negative root. What if I use minus 1? I would get minus 1 plus 2 minus 4 plus 8. 2 plus 8 equal to 10. Minus 1 minus 4 is minus 5. So it's not equal to 0. So that means m is equal to minus 1 is not right. So the next number I would use m minus equal to minus 2. I would get minus 8 plus 8 minus 8 plus 8 is equal to 0. So that means another root is m plus 2. Then I use m plus 2 dividing this equation. So I would get m squared plus 4. Now I know that another next two root is plus minus 2i. So I know that I have 4 value of m, which is minus 1, minus 2, and 2i, and minus 2i. So my axis is equal to this. I know xc, next I want to find xp. My xp, I'm going to use the shortcut method, so in that case I have to write down my differential equation in the terms of operator d. Okay, so I would get and times exponential of 0t. Okay. Test 2. Our a is equal to 1. You put a in every term of ud. So you got 1 here, 1 plus 3 plus 6 plus 12 plus 8. Equal to what? 30, right? So we got 3 over 30 exponential of t. And this one a is equal to 0. You put 0 into every term of t, you would get 8. 1 over 10 exponential t minus 3. That is our xp. So now, say that our x is equal to xc plus xp, which is equal to this. Get x next y. Again, doing the determinant. Now, the function on your right hand side got to be replaced as the coefficient of y. And the denominator is just the same as the x, so you write down. You just can take an x case to write down. You don't need to do the finding the determinant again, okay? Because it's just exactly the same as the case of x. There you go. We put the coefficients of x there. And for the coefficients of y, we use the function on the right hand side. And we will get is up here. Then the determinants on top, we would get minus times exponential of t. Okay? Plus 8 here, we got 3d squared 8 plus 3d 8 plus 16 minus 2d squared exponential of t plus d exponential of t plus 2 times exponential of t. That is so. And then second derivative of 8 is equal to 0. First derivative of 8 equal to 0. Then get 16. The second derivative of exponential of t is equal to exponential of t. The first derivative of exponential of t is equal to exponential of t. Okay, almost done. Such a long example. You have 16 here, minus 2 plus 2 are gone, and then you have exponential. Like I said, that the term that you're going to find yc is equal to the terms that you're going to find xc. So in this case, you don't need to do yc again. You can just copy it from x, so you know that your yc is equal to and now you got to find yp. You find yp by using this. We got 16 times 1 over and times exponential of 0t. Exponential of t. Okay. Put a equal to 0 into every term of t, you would get 1 over s. So 16 over 8 plus a is equal to 1. Put 1 into every term of t, 1 over 30, or 2 plus 1 over 30 exponential of t. Now your y is equal to yc plus yp you would get this, and that's the answer. Any questions?